Shri Guru Pyo Namaha children. In last session, we have discussed about stacks. Today in this session, we are going to discuss about queue. A queue is a data structure that is based on first in first out strategy. That is, the element that is added to the queue is the first element to be removed from the queue. Queue follows FIFO, that is first in first out structure it follows. According to FIFO structure, elements inserted first will be the removed first. That is, whichever element is being inserted into your queue is the first element to come out from the queue. Queue has two ends. One is called as your front end, the other end we call it as back end or rear end of the queue. Items are added to the queue at the rear end and removed from the queue at your front end. In a queue, one end is always used to insert the data, which we call it as a end queue. That is, the insertion of data will be done through your rear end. So we call it as end queue. The other end is used to delete the data. That is, using your front end, we use to delete the data, which we call it as a DQ, because queue is open at both the ends. So one end we call it as an end queue, the other end we call it as a DQ. So the insertion of elements is always at the rear end. That is, insertion and deletion happens at different ends. So the insertion, which is nothing but in your rear end, which we call it as a end queue, the elements is being added to the queue, and the deletion of elements which we done at the TQ. So using your front end, we delete the elements. That is, elements will come out from the queue. So this is the basic examples of your queue. Queue is just like a queue. That is, these are the day-to-day examples of queue, like a standing in a cinema hall, booking your railway tickets, and Indian bank counters or in a bank counters, whatever it is. Application. So where and all we are using the queue. Sharing of one resources among multiple users, such as sharing printer among multiple computers. That is, if I have only one resources, if I want to use it for multiple computers, in the sense all the computers may request a job to the same printer. So the job will be scheduled in such a way as it has been queued to the program. CPU uses queues to implement round-robin scheduling among its waiting process. Playlist ordering, that is, buffers on MP3 player and portable CDs, or it may be in iPod playlist, add songs to the end and play from the front end of the list. In airport authorities, that is the use of a queue in a situation sharing a single runaway from both landing and taking off your flights. These are the basic examples of queue. Here, we have two operations here based on your queue. One is your insertion, the other one is going to be a deletion. So insertion always will be done from your rear end. So initially your queue is empty and we try to insert the elements from the into the queue. That is 24 we are inserting, that is in the front end, that is from through your back, that is it is being inserted as a first element is being inserted. So that will become the first, as we are inserting only one element. So this becomes my front and rear. As we don't have any elements in your queue, this becomes both rear and front. So the next element we are inserting, that is 56 if we are inserting in the sense, that becomes a rear and this becomes your front. So your rear end, which is nothing but 56, your front, which is nothing but 24. So in rear end only, using your rear only, we are going to insert the elements. Again, we are inserting 4. So this element becomes a rear and front remains as it is. Next, we are inserting 9 and next we are inserting 2. That is, the rear is the last element that we have inserted. Front remains same as it is. This is how insertion takes place in your queue. In deletion process, always your deletion will be done from your front end. So which is your front element? This is going to be your front element and this is going to be your rear element. So deletion process will done at the front end. So once we have deleted your front, the front will be shifted to the next element in your list, which is nothing but 56, right? So again, if you are deleting the element of 56 in the sense, front will be pointing to F. That is 4, it will point F. Front will point to 4. Again, if you are deleting 9 in the sense, 4 if you have deleted in the sense, it points to 9. Again, if you delete 9 in the sense, it points to 2. That is, whenever we are deleting, only front gets changed. Rear remains as it is. Whenever we are inserting elements, front remains same and rear gets changed, right? So once we have deleted all the elements in the queue, your queue is empty. So how we are going to implement the operations using your peek, NQ and DQ. Peek, which is nothing but we are going to use the list structure of structure to implement your queue operation, right? Here we assume that queue is going to be your list and based on your front and rear elements, we are going to insert and delete the elements from your queue. Front is an integer storing the position of the first element in the queue. So from which is nothing but you are in a list, your front element starts from 0 and to the last element in your list. So every time that you are going to add the elements, in the sense the front keeps on incrementing its value to the last element in your list. NQ is the process that is to insert an element, that is you are going to add the elements into the queue or you are going to push the elements into your queue. So we use a function called as your append. So this is used to push the element, that is the item is being pushed into the queue. The item will be added at the rear end of the queue. If you want to delete the elements, in the sense we have to use a pop of 0, which means that you are deleting the first value or the first element from the queue. So we'll be referencing the pop with the subscript, that is with your parameter as a 0 value. So how will you calculate the number of elements? Number of elements will be calculated as rear minus front plus 1. Suppose if I have total 10 number of elements in the sense, using my list structure, always front will be referenced as 0, rear will be referenced as the last number of elements minus 1, which is nothing but 9. So this is your front value and this is going to be your rear value. So to calculate the total number of elements, right? Number of elements equal to, what is your rear value? 9 minus 0 plus 1, which gives 10. So which is nothing but the total number of elements in your queue. Python implemented through a list, front and rear as. So always your front will be 0 and rear, which is nothing but the length of the queue. So what is the length of your queue? 10. 10 minus 1 is 9. So the last index of your list value is 9 in your queue. Now we'll execute the program, how to work, how the operations that we are going to work in a queue. Now this is our program that we are going to do the operations based on your queue implementations. Here we are going to discuss the program based on your menu driven method. So these are the menus that we are going to work, which is nothing but the operations that you are going to work with the queues, right? So NQ, which is nothing but insertion, DQ, which is nothing but deletion, peek, which is nothing but it shows the last element in your queue, and display to display the all the elements from your queue, and finally if you press 5 in the sense we are going to exit the exit the program. Here Q equal to an empty list, right? Initially we have not inserted any elements into the queue, so it is empty now. Front equal to none, which means that once the value is being inserted only, we are going to change the value of front and rear. So initially it is we don't have any elements there, so the front is none. So here this is your menu driven program. So if I give the choice as 1 in the sense, I'm going to get the item from the user, then I'm going to call the function called as enqueue, and whichever the item that I'm going to insert into the queue, I'm going to pass it to the function and I'm going to insert the value, right? So here is the function queue of item, that is I'm going to insert the value, that is item I'm going to insert into the queue. So queue dot append of item, that is a value being inserted into the queue using your append function. So if the length of the queue is 1, right? So only one element is present in your queue, so my length is 1. So as I have only one element in my queue, both front and rear is 0, right? So if more number of elements that I have inserted into the queue in the sense, this function, that is this if statement fails over there, so it goes for a else part and it checks with the rear value, that is length of queue minus 1. Suppose if I have 5 elements in my queue in the sense, 5 minus 1 is 4, that is rear is pointing to the indexing in your list indexing as 4. Now the second choice is DQ, which is nothing but deletion of elements. So whichever element that I'm going to delete from the queue, I'm going to store it in an item. So we'll see how the function is, right? DQ, that is which queue we are going to delete it. If no elements is present in my queue in the sense, furthermore I cannot able to delete the values from my queue, so I'll return the statement as underflow. If I have elements in the sense, I'm going to delete the element. Which element I'm going to delete? The first element or the front element I'm going to delete. So q dot pop of 0, that will be stored in your item and that item will be returned, right? So if q of length of q is 0, that is no element is being present in my queue in the sense, I cannot able to delete the elements from my queue. So further I'll be giving it as none. So I further I cannot able to delete the elements. Otherwise I'll be passing the deleted elements to the main program. So once I get the deleted element, I'll check whether it is an underflow or not, which means that I don't have any elements to be deleted. So in such case, it just displays the message as underflow, queue is empty. Otherwise, which element that you are going to delete, that item gets displayed. The third option is displaying the last, that is last or the rear element in your queue, that is peak of queue. Peak, that is if your queue is empty, furthermore you are not going to delete the elements, so you will return the message as underflow. If I have element in the sense, the element will be returned, that is different element will be returned. So queue of front is will be returned, that is that particular element is being returned to the function. The next choice is display, that is displaying, which is nothing but processing all the elements in your queue and displaying all the elements in your queue, right? So when it is being displayed, if it is empty in the sense, queue is empty. If it is 1 in the sense, I have only one element, that is going to be my front and rear element. Otherwise front equal to 0, length equal to, that is rear equal to length of queue minus 1. So first element I have printed here using my print of 0. So here I'll be using a for loop to print all the elements till the rear end. So 1 comma rear. So based on your incrementing value of the loop variable, each variable, that is each queue element is being printed, and finally the last element we are going to print and we are showing that is going to be your rear element in your queue. And the last thing is choice is 5, which means that we have completed all the operations. We are going to give the exit button. Now let us execute this program. So these are the options. First we are going to insert the element 1, item is 11, continue, again 1, 22, right, again 1, 33, again 1, 44. Now we'll go for a fourth option to display the elements, number 4, right. So number 4, which is nothing but displaying the queue. So sorry, right. So these are the options that we have. The first one is insertion, item 11, press continue, again 1, item is 22, again press continue, again 1, item is 33, again 1, item is 44, again 1, again 1, item is 55, right. So now we'll display the values, right. Your option is 4. See, each time that you are going to insert the elements in your queue, in the sense it is being added. So the first element that we have inserted is your front element, and the last element that we have inserted is your rear element. Now we'll go for the option as 2, that is we are going to delete the elements. So DQ, that is item, the front item gets deleted. Let us check with that. We'll go for the option 4, right. So 11 is being deleted. So what is the next element in your queue, which is nothing but 22? That becomes as your front element. So the third option. Now we'll go for a third option, that is frontmost item is your 22, right. So now this is how your queue operations works. NQ, which is nothing but for insertion, 2 is for, that is DQ is for deletion, peek is for viewing the front element, display is for displaying all the elements in your queue, and 5 is for exit. So now I'll give the exit command. Okay, thank you children. Okay, so today we have seen how to work with the queue operations. Okay, to receive our online lessons, please press the subscribe button and you will receive the latest updates. Thank you children.